Connecting chain-hung fixtures with electrical metallic tubing or end-to-end is not okay. The National Electrical Code, or NEC, Section 358.30 a violation is significant. Unsupported EMT is prone to vibration and movement, which can damage the electrical connections and create a safety hazard. EMT is not designed to be used as a rigid support for fixtures. Metal-clad cable, or MC cable, is a better option because it is a flexible metal conduit that provides both mechanical support and electrical protection for conductors. It is commonly used for supporting chain-hung fixtures because it can withstand vibration and movement. Your proposed solution of rewiring the rows with MC cable and dropping down the chain from a new box with MC is correct and meets the code requirements. National Electrical Code Section 358.30 states conduits shall be securely fastened in place and shall be mechanically and electrically continuous. National Electrical Code Section 410.67 states chain-hung fixtures shall be supported by the conduit supplying the fixture. It is not safe or code compliant to connect chain-hung fixtures with EMT end-to-end. Rewiring the rows with MC cable and dropping down the chain from a new box with MC is the recommended and compliant method. The reason that EMT is not suitable for this application boils down to its inherent rigidity and the nature of chain-hung fixtures. Chain-hung fixtures, by design, are intended to have some degree of flexibility in movement. This movement can be caused by various factors, including vibrations from machinery, building movement, or even just air currents. And, being a rigid conduit, does not accommodate this movement well. When EMT is used to connect chain-hung fixtures end-to-end without proper support, it creates a rigid assembly that is susceptible to stress and strain. This can lead to several problems. Firstly, the EMT itself can become damaged over time. The constant vibration and movement can cause the EMT to loosen at the connections, bend, or even break. Secondly, the electrical connections within the EMT can be compromised. The vibration can cause the wires to loosen from the terminals, leading to arcing, short circuits, and potentially even electrical fires. Thirdly, the fixtures themselves can be damaged. The rigid connection to the EMT can transfer stress to the fixtures, causing them to crack, bend, or even fall from the ceiling. In contrast, MC cable is a flexible conduit that can accommodate the movement of chain-hung fixtures without placing undue stress on the electrical connections or the fixtures themselves. MC cable consists of insulated conductors wrapped in a flexible metal sheath. This sheath provides mechanical protection for the conductors while also allowing the cable to bend and flex without damage. When MC cable is used to support chain-hung fixtures, it can absorb the vibrations and movement without transferring stress to the fixtures or the electrical connections. This helps to ensure the safety and reliability of the electrical system. Your proposed solution of using MC cable to rewire the riser fixtures and dropping down from a new box is a good one because it addresses the issues associated with using EMT to connect chain-hung fixtures. By using MC cable, you are providing a flexible and reliable means of supporting the fixtures that can withstand the vibrations and movement without compromising the electrical connections. Furthermore, by dropping down from a new box, you are ensuring that the fixtures are properly supported and that the weight of the fixtures is not placed on the EMT. This is important because EMT is not designed to support the weight of fixtures, and doing so can lead to the EMT sagging or even collapsing. In addition to the safety benefits, using MC cable can also improve the aesthetics of the installation. MC cable is typically smaller and more flexible than EMT, which means that it can be routed more easily and concealed more effectively. This can result in a cleaner and more professional-looking installation. The specific National Electrical Code sections that are relevant to this situation are Section 358.30 and Section 410.67c. Section 358.30 requires that EMT be securely fastened in place and that it be mechanically and electrically continuous. This means that the EMT must be properly supported and that all connections must be tight and secure. Section 410.67c states that chain-hung fixtures must be supported by the conduit supplying the fixture. This means that the conduit must be strong enough to support the weight of the fixture and that the fixture must be securely attached to the conduit. In summary, using EMT to connect chain-hung fixtures end-to-end without proper support is a violation of the National Electrical Code and can create a safety hazard. MC cable is a better option because it is flexible and can accommodate the movement of the fixtures without compromising the electrical connections. Your proposed solution of using MC cable to rewire the rows of fixtures and dropping down from a new box is a good one that will ensure the safety and reliability of the electrical system. Now let's delve a little deeper into the specifics of why EMT is unsuitable for supporting chain-hung fixtures and why MC cable offers a superior alternative. We'll explore the mechanical and electrical properties of each conduit type, the relevant code requirements, and the practical considerations that make MC cable the preferred choice in this scenario. EMT, or electrical metallic tubing, is a type of rigid metal conduit commonly used in electrical wiring installations. It is typically made of steel or aluminum and is available in various sizes and thicknesses. EMT is designed to protect electrical conductors from physical damage and to provide a grounding path for electrical systems. While EMT is strong and durable, it lacks the flexibility required to properly support chain-hung fixtures. When EMT is used to connect chain-hung fixtures end-to-end without adequate support, it creates a rigid assembly that is prone to vibration and movement. This can lead to several problems, including damage to the EMT, loosening of electrical connections, and potential safety hazards. The rigidity of EMT is a major drawback in this application because chain-hung fixtures are inherently flexible. They are designed to move and sway slightly, whether due to vibrations from machinery, building movement, or even air currents. When EMT is rigidly connected to these fixtures, it restricts their natural movement and places undue stress on the conduit and the electrical connections. This stress can lead to fatigue and eventual failure of the EMT, especially at the joints and couplings. Furthermore, a vibration and movement can cause the electrical connections within the EMT to loosen over time. This can result in arcing, short circuits, and even electrical fires. In contrast, MC cable, or metal-clad cable, is a flexible metal conduit that is specifically designed for applications where flexibility is required. MC cable consists of insulated conductors wrapped in a flexible metal sheath. This sheath provides mechanical protection for the conductors while also allowing the cable to bend and flex without damage. The flexibility of MC cable is a key advantage in supporting chain-hung fixtures because it allows the fixtures to move and sway without placing undue stress on the conduit or the electrical connections. The flexible metal sheath of MC cable absorbs the vibrations and movement, preventing them from being transmitted to the electrical connections. This helps to ensure the long-term reliability and safety of the electrical system. In addition to its flexibility, MC cable also offers excellent electrical protection. The metal sheath provides a continuous grounding path for the electrical system, helping to prevent electrical shocks and fires. MC cable is also resistant to moisture, chemicals, and other environmental factors, making it suitable for a wide range of applications. When it comes to National Electrical Code requirements, Section 358.30 specifically addresses the support of EMT. This section requires that the EMT be securely fastened in place and that it be mechanically and electrically continuous. This means that the EMT must be properly supported and that all connections must be tight and secure. In the case of chain-hung fixtures, this requirement can be difficult to meet when using EMT. The weight of the fixtures combined with the vibrations and movement can place significant stress on the EMT supports, potentially leading to failure. Section 410.67c provides further guidance on the support of chain-hung fixtures. This section states that chain-hung fixtures must be supported by the conduit supplying the fixture. This means that the conduit must be strong enough to support the weight of the fixture and that the fixture must be securely attached to the conduit. Again, this requirement can be challenging to meet when using EMT, especially when the fixtures are heavy or subject to significant vibration. MC cable, on the other hand, is specifically designed for supporting fixtures and other electrical equipment. Its flexibility and strength make it an ideal choice for this application. When properly installed, MC cable can provide a secure and reliable support system for chain-hung fixtures, ensuring that they are safely and securely mounted. From a practical standpoint, MC cable offers several advantages over EMT in this application. Firstly, MC cable is easier to install than EMT. Its flexibility allows it to be routed around obstacles and through tight spaces more easily. Secondly, MC cable requires fewer supports than EMT. This can save time and money on installation costs. Thirdly, MC cable is more resistant to damage than EMT. Its flexible metal sheath can withstand impacts and vibrations without cracking or breaking. In conclusion, while EMT may be suitable for some electrical wiring applications, it is not the best choice for supporting chain-hung fixtures. The rigidity of EMT can lead to stress in the conduit and electrical connections, potentially resulting in damage and safety hazards. MC cable, with its flexibility, strength, and ease of installation, is a superior alternative for this application. By using MC cable to support chain-hung fixtures, you can ensure the safety, reliability, and longevity of the electrical system. Now let's consider some additional factors that further solidify the case for using MC cable over EMT for chain-hung fixture installations. These include the potential for condensation within the conduit, the ease of making modifications or repairs, and the overall cost-effectiveness of each option. Condensation can be a significant issue in electrical conduit systems, especially in environments with fluctuating temperatures or high humidity. When warm, moist air enters the conduit and comes into contact with cooler surfaces, condensation can form. This condensation can then accumulate inside the conduit, potentially damaging the electrical conductors and causing corrosion. EMT, being a rigid metal conduit, is more susceptible to condensation buildup than MC cable. The smooth, continuous interior surface of EMT provides an ideal environment for condensation to form and accumulate. In contrast, MC cable's flexible metal sheath is not as prone to condensation. The corrugated surface of the sheath provides less surface area for condensation to form, and the gaps between the corrugations allow for better ventilation, which can help to prevent condensation buildup. Furthermore, the insulation around the conductors in MC cable provides an additional layer of protection against moisture damage. If condensation does form inside the MC cable, the insulation helps to prevent it from coming into direct contact with the conductors, reducing the risk of corrosion and electrical problems. When it comes to making modifications or repairs to the electrical system, MC cable offers greater flexibility and ease of access compared to EMT. With EMT, any modifications or repairs typically require cutting, threading, and reassembling the conduit. This can be a time-consuming and labor-intensive process, especially in tight or difficult-to-reach locations. In contrast, MC cable can be easily cut and spliced using standard electrical connectors. This makes it much easier to make modifications or repairs to the electrical system without having to disassemble the entire conduit run. Furthermore, the flexibility of MC cable allows it to be easily rerouted or extended as needed, without requiring extensive cutting and reassembling. From a cost-effectiveness standpoint, MC cable can often be a more economical choice than EMT, especially when considering the total cost of installation and maintenance over the lifespan of the electrical system. While the initial cost of MC cable may be slightly higher than EMT, the savings in labor costs due to easier installation and reduced maintenance can often offset the higher material cost. MC cable requires fewer supports than EMT, which can further reduce installation costs. Additionally, the longer lifespan of MC cable, due to its resistance to corrosion and damage, can result in lower maintenance costs over the long term. When considering the overall cost-effectiveness of MC cable versus EMT, it is important to factor in all of these factors, including material costs, labor costs, maintenance costs, and the potential for downtime due to repairs or modifications. In many cases, MC cable will prove to be the more economical choice in the long run, even if the initial material cost is slightly higher. In addition to the factors discussed above, there are also some specific applications where MC cable is particularly well suited for supporting chain-hung fixtures. These include environments with high levels of vibration, areas where flexibility is required due to building movement, and locations where aesthetics are a concern. In environments with high levels of vibration, such as factories or manufacturing plants, MC cable's flexibility and resistance to vibration damage make it an ideal choice for supporting chain-hung fixtures. The flexible metal sheath of MC cable absorbs the vibrations, preventing them from being transmitted to the electrical connections and reducing the risk of damage. In areas where flexibility is required due to building movement, such as in high-rise buildings or structures subject to seismic activity, MC cable's ability to bend and flex without damage makes it a superior choice over rigid EMT. The flexibility of MC cable allows it to accommodate the building's movement without placing undue stress on the electrical connections or the fixtures themselves. In locations where aesthetics are a concern, such as in retail stores or office buildings, MC cable's smaller size and flexibility make it easier to conceal than EMT. MC cable can be routed through tight spaces and hidden behind walls or ceilings, resulting in a cleaner and more professional-looking installation. In summary, when it comes to supporting chain-hung fixtures, MC cable offers numerous advantages over EMT, including greater flexibility, resistance to vibration and condensation, ease of installation and modification, and overall cost-effectiveness. By choosing MC cable for this application, you can ensure the safety, reliability, and longevity of the electrical system, while also achieving a cleaner and more professional-looking installation. Now let's think about the grounding implications of using MC cable versus EMT for chain-hung fixtures. Grounding is a critical aspect of electrical safety, and it's essential to ensure that the chosen wiring method provides a reliable grounding path. Both MC cable and EMT can provide a grounding path, but they do so in slightly different ways. EMT relies on the metal conduit itself to serve as the grounding conductor. When EMT is properly installed and all connections are tight and secure, it creates a continuous metallic path back to the grounding electrode. This path allows fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. However, the effectiveness of EMT as a grounding conductor depends on the integrity of the connections. If the connections are loose or corroded, the grounding path can be compromised, increasing the risk of electrical shock. MC cable, on the other hand, typically includes a dedicated grounding conductor within the cable itself. This grounding conductor is a separate wire that is specifically designed to carry fault current back to the source. The grounding conductor in MC cable provides a more reliable grounding path than relying solely on the metal conduit. Even if the connections in the MC cable become loose or corroded, the dedicated grounding conductor will still provide a path for fault current to flow. In addition to the dedicated grounding conductor, the metal sheath of MC cable also contributes to the grounding path. The metal sheath provides a low impedance path for fault current to flow, helping to quickly trip the circuit breaker and minimize the risk of electrical shock. When installing MC cable for chain-hung fixtures, it's essential to properly terminate the grounding conductor at both ends of the cable. This typically involves connecting the grounding conductor to a grounding terminal in the junction box and to a grounding lug on the fixture. It's also important to ensure that the metal sheath of the MC cable is properly bonded to the grounding system. This can be achieved by using appropriate connectors and fittings that are designed to provide a secure and reliable bond between the metal sheath and the grounding electrode. In some cases, local electrical codes may require the use of additional grounding measures, such as supplemental grounding electrodes, to further enhance the grounding system. It's important to consult with a qualified electrician to determine the specific grounding requirements for your installation. When comparing the grounding capabilities of MC cable and EMT, MC cable generally offers a more robust and reliable grounding path due to the presence of a dedicated grounding conductor and the additional grounding provided by the metal sheath. This makes MC cable a safer choice for supporting chain-hung fixtures, especially in environments where grounding is critical, such as in hospitals, schools, and industrial facilities. Now, let's address a common misconception regarding the use of flexible metal conduit, or FMC, in place of MC cable for chain-hung fixture installations. FMC is another type of flexible metal conduit that is often used in electrical wiring applications. However, FMC is not typically recommended for supporting chain-hung fixtures, and it's important to understand the reasons why. FMC is similar to MC cable in that it consists of insulated conductors wrapped in a flexible metal sheath. However, FMC differs from MC cable in that the metal sheath is not as robust or as tightly interlocked as the sheath of MC cable. This makes FMC less resistant to physical damage and less suitable for supporting heavy loads. In addition, FMC typically does not include a dedicated grounding conductor. This means that the grounding path relies solely on the metal sheath, which can be less reliable than the grounding path provided by MC cable with a dedicated grounding conductor. For these reasons, FMC is generally not recommended for supporting chain hung fixtures, especially in applications where the fixtures are heavy or subject to significant vibration. MC cable provides a more robust and reliable support system for chain hung fixtures, and it's the preferred choice in most situations. While FMC may be suitable for some limited applications, such as connecting a short run of wiring to a motor or other piece of equipment, it's not a suitable substitute for MC cable when it comes to supporting chain hung fixtures. Always consult with a qualified electrician to determine the appropriate wiring method for your specific application. Now, let's consider the potential impact of using LED lighting fixtures in place of traditional fluorescent fixtures on the choice of wiring method for chain hung installations. LED lighting has become increasingly popular due to its energy efficiency, long lifespan, and other advantages. However, the use of LED fixtures can also have implications for the electrical wiring system. LED fixtures typically draw less current than traditional fluorescent fixtures. This means that the wiring system can often be downsized, which can result in cost savings. However, it's important to ensure that the wiring method is still appropriate for the application, even with reduced current draw. MC cable is still a good choice for supporting chain-hung LED fixtures. The flexibility and strength of MC cable make it well suited for supporting the fixtures, and the dedicated grounding conductor ensures a reliable grounding path. Even though the current draw of LED fixtures is lower than that of fluorescent fixtures, it's still important to follow all applicable electrical codes and standards when installing the wiring system. This includes properly sizing the conductors and overcurrent protection devices, as well as ensuring that all connections are tight and secure. In some cases, the use of LED fixtures may allow for the use of smaller diameter MC cable. This can result in further cost savings and make the installation easier. However, it's important to consult with a qualified electrician to determine the appropriate size of MC cable for your specific application. In general, the use of LED lighting fixtures does not significantly change the recommendations for wiring methods for chain-hung installation. MC cable remains a good choice for supporting the fixtures, and it's important to follow all applicable electrical codes and standards to ensure a safe and reliable installation.